So let's just see the another question. The question number 4 says use Euclid's lemma to show that the square of any positive integer is either of the form 3m or 3m plus 1 for some integer m. So now we have to show that the square of any positive integer means we have to take any positive integer and then we have to take a square of that particular positive integer. Then it is either of the form 3m or it is of the form 3m plus 1 where m can be any particular integer. So let's just start the solution set of this particular question. As we know that we have to use the Euclid's lemma over here. So the solution set of this particular question will be like, let a be any positive integer. Let a be any positive integer and we are taking b over here as 3 because we just wanted to prove that either it is of the form 3m or 3m plus 1. So by Euclid's lemma, we know that a can be of the type bq plus of r with a condition that the value of r can lie in between 0 and b. So let us suppose we are starting the solution set or we are using the Euclid's lemma over here. Substitute the value of b in it. We get the answer as a is equal to b is nothing but 3q plus of r, and the value of r is lying in between 0 and 3. 3 is nothing but b. So it means that the value of r, the possible values of r can be 0, 1 and 2. It cannot be 3 obviously. So let's just start the making the cases. So let us suppose I'm taking the case number 1 in which we are taking r as 0 in the equation number 1. So let us suppose I'm calling it as equation number 1. So substituting r is equal to 0 in the equation number 1, we get the answer as a is equal to 3q plus of 0. Now a is equal to 3q, but the question says we have to take the square of the positive integer. It means we have to take the square of this particular equation. So let us suppose I'm calling it as equation number 1. So squaring both sides, the further step will be squaring both sides because we are concerned about the square of the positive integer, not about the positive integer itself. So taking the square both sides, so squaring both sides means it will be of the type a square is equal to 3q square. Again further we can say that it is of the type a square is equal to 9q square, and let us suppose I can write it in the formation of 3 into 3q square. So we know that a square can be written in the formation of 3m where m is of the type 3q square. I am taking 3q square as m over here because as per the question m can be any integer for some integer m. So I am taking m in this particular equation as 3m square and substituting 3q square as m in place of this. So it can be of the formation a square is equal to 3m. So the very first condition of ours is actually proven that the square of any positive odd integer is either of the form 3m plus 1. So here we have proved that the square of any positive integer is of the form 3m. So let's just move on to what the case number 2. So the case number 2 will be like the value of r is nothing but 1. So substitute the value of r as 1. So we know that when we will substitute the value of r as 1, it will be like a is equal to 3q plus of 1. But we are not, we just do not want to prove a is equal to 3q plus 1 type, but we just wanted to take a square of it. So let us suppose I'm calling it as equation number 3. So squaring both sides, we are taking the square of both sides. So it will be like a square, which is equal to 3q plus 1 whole square. So let us suppose I am expanding this 3q plus 1 whole square by using the algebraic identity as a plus b whole square. We know that what is a plus b whole square. So let us suppose I am writing a plus b whole square over here as a square plus b square plus 2ab. Using this particular algebraic identity, I am expanding this 3q plus 1 whole square. So it can be written as 3q whole square plus 1 square plus 2 into 3q. So after solving this, we get the answer as a square is equal to, it is 9q square plus of 1 plus of 6q. So let us suppose I am rewriting it again as 9q square plus of 6q plus of 1. And we know that in the first two terms, we can take 3 as common. So it will be like 3q square plus of 3 into 2 is 6, 2q plus of 1. So let us suppose I am writing this number as nothing but m. So a square will be of the type 3m plus 1, where m is 3q square plus of 2q of type. So hence at the end, it is all proven that the square of the number is now of the type 3m plus 1, where m can be any particular integer. So I have actually substituted this particular number as m. You can substitute any particular number over here as any number, but in this particular question, it is given to us that we have to take the number as 3m or either 3m plus 1 for some integer m. So that is why I have taken this number as m. So at the end, we have proven that a square is again of the type 3m plus 1. So let's just move on further toward the case, which is the case number 3rd. So let us we are taking, or we are talking about the case number 3rd, in which r is nothing but 2. Now substitute r is equal to 2 in the equation. It will be like a is equal to 3q plus of 2. Now we have to take the square. So basically we are doing squaring both sides. We get the answer as a square is equal to 3q plus 2 whole square. Again, we can use the algebraic identity over here. It will be like of the type, let us suppose I'm writing it by expanding it. So it will be like 9q square plus 2 square, that is 4, plus 2 into 3, 6. 6 into 2 is nothing but 12. So it is 12q. Now I am rewriting it again. The answer is 9q square plus of 12q plus of 4. So let us suppose I'm talking about taking 3 common from this particular bracket, but we can also take 3 common from this number 4. So let us suppose I'll rewrite it again. We can write it in the formation as a square is equal to 9q square plus of 12q plus of 3 plus of 1, because we know that 4 can be written as 3 plus 1. So now we have 3 numbers in a bracket and we can take 3 common from this particular bracket. So this will be like 3q square plus of 3 into 4 is 12 plus of 3 into 1 is 3 plus of 1, and we can write this particular number as nothing but m. So a square is of the type 3m plus of 1, where m is nothing but of the form 3q square plus of 4q plus of 1. So hence at the end we have proved that the square of any positive integer is either of the form 3m or either of the form 3m plus 1, where m is any integer or for some integer m. I hope the solution set of this particular question is all clear to you. So let's just move on further.